So here's problem number 11 from section 4.1. We're going to use analytic methods to find out find the values of the extremes. Let's start out by finding all the candidates for those extremes. How about we find out what f prime of x is equal to? I believe the derivative of 1 over x is negative 1 over x squared. I believe the derivative of natural log of x is 1 over x. And now, in order to find out values, critical values, we have to ask of that derivative, what values of x on our interval are either undefined, or what values of x on that interval are make the derivative equal to 0. Well, it looks to me like 0 would make that derivative undefined. Is that correct?
Yes.
But 0 isn't in our interval, so we don't have to worry about 0. Are there any values that are going to make that derivative equal to 0? Let me see if I can come to the same conclusion. I want to find a common denominator here. I end up with negative 1 over x squared plus x over x squared, which gives me x minus 1 over x squared. And now I'm interested, what values of x make that numerator 0? X minus 1 equals 0 when x is equal to 1. So I agree that 1 is the x coordinate of a critical point. So let's make a list of our candidates for extrema. Our candidates consist of x equals 0.5, x equals 4, and x equals 1. Those are our candidates. If I find out what f of 0.5 is, I get 1 over 0.5 plus the natural log of 0.5. This is equal to 2. Minus the natural log of 2. The book does that change it quite a bit. The natural log of 1/2, I'll write it over here. The natural log of 1/2 is equal to the natural log of 2 to the negative 1 power, which is equal to negative natural log of 2. So almost all the time when they say the natural log of 1/2, they do that change. Okay, I don't know what that value is.
It leaves it there.
What's that?
I think it just leaves it there.
Leaves it that way? Okay, let's find out what is f of 4. This would be what? 1/4 plus the natural log of 4, which is 1/4 plus 2 natural log 2.
So it's like when you have a radical, sometimes they want you to simplify it as much as possible.
And then lastly, what about f of 1? 1 plus natural log of 1, but natural log of 1 is 0, so it's just 1. Okay. So, which one of those three values, 2 minus natural log of 2, 1/4 plus 2 natural log of 2, and 1, which one of these values is the largest?
Say what you need a calculator for.
This one's the largest. How did I know that? I asked myself the question, what is the approximate value of the natural log of 2?
Well, it's log base b2, so b is equal 7 something, so for it to be equaling to about 2, e raised to some power to equal 2 would have to be less than 1.
Okay. The natural log of 2 is between, I can't draw, 0 and 1. Is that right?
Yes.
If I had to raise it, put a power, an exponent onto e to get to 2, e to the 0th is 1, e to the first is e, which is about 2.7. It's some number between 0 and 1. So when I look at this, I'm saying this is 2 minus some number between 0 and 1. What about here? 1/4 plus 2 natural log 2.
Will be 2 times a number between 0 and 1.
Right?
So it would be the smallest, because that would be, no matter what, that'd be, well, it could be more or less than 1, depending on what ln of 2 is equal to.
Okay.
But you know it's gonna be less than 1, but if it's less than 3/4.
Do I know it's going to be less than 1? If natural log of 2 is close to 1, then this is going to be close to 2, 2 1/4? Maybe?
Right, so
Yeah,
that's why.
I'm not so confident in this anymore.
Yeah, see, that's why I was
That's
confused.
not right.
Yeah, because if L1 2 is like 0.9, then the middle.
Yeah, I think at this point where I'm desperate to. So let's find the decimal versions of that,
Right.
because I think all three of these are right around 1 now. As the more I look at them. What do we got?
The first one is 1.317.
317. Thank you for 3 decimal places, which is what I required.
The second,
1.636.
6. And this one, I think I know this one. This is 1. Okay, so we declare this one to be the absolute max. We declare this one to be the absolute min. This one, by the way, do we know whether this is a local maximum or a local minimum?
It could be either, couldn't it?
Here's how I would attack that problem. I'm going to ask you to think about the derivative function for just a little bit. And I know the derivative function has a 0 when x is 1. Is that because we calculated that, right? 1 is the x component of a critical point. Just prior to 1, what kind of values come out of the derivative? If x is less than 1, I get a negative on top, a positive on the bottom.
Negative.
I've got negative derivatives to the left of 1. When I'm to the right of 1, when I'm greater than 1, I got positive. What kind of function looks like that? It goes down and it comes up.
Quadratic.
Okay, well, quadratics look that way too, but I just want you to think about, here's where we said the absolute min was. Here's where we said the absolute max was. What about over here? It's a local max. And by looking at the derivative, I can determine that.
Oops.
And also we could think about this is 1.3, this is 1.6, and there's 1. And you can, and how do I know that this is always decreasing between here? Answer, because the derivative only has one place where it can change sign. It can only change sign when either derivative is 0 or undefined. So this, again, will have to be a local max. And that's problem number 11. I really wish I could have done those natural logs in my head. It would have been very impressive. Oh well.
It is very impressive anyways.
I thought I could do it. Oh well. All right, number 11 done.